The universe is vast. We humans have always looked up at the stars and wondered. Now imagine a computer as powerful as the cosmos itself. A computer that can solve problems in minutes, problems that would take classical computers billions of years. This is the promise of quantum computing. We are on the cusp of a new era. An era where the strange and counterintuitive laws of quantum mechanics are harnessed. This is not just an upgrade, it is a revolution. This is a journey into the heart of quantum computing. We will explore its history, its potential, and the challenges that lie ahead. Fasten your seatbelts. We are about to embark on an extraordinary adventure. Our story begins in the early 20th century. Physicists like Niels Bohr and Albert Einstein were grappling with the bizarre world of quantum mechanics. They discovered that the subatomic realm operates very differently from our everyday world. In the 1980s, the idea of quantum computing emerged. Physicist Richard Feynman and others realized something amazing. They realized that quantum systems could be used to perform computations in a completely new way. These pioneers laid the foundation for a new kind of computer. A computer that could exploit the strangeness of the quantum world. At the heart of a quantum computer lies the qubit. Think of a qubit as the quantum equivalent of a bit in a classical computer. A classical bit can be either 0 or 1, but a qubit can be in a superposition. Imagine a coin spinning in the air. It's not heads and it's not tails. It's in both states at the same time. That's superposition. A qubit can be both 0 and 1 simultaneously. This allows quantum computers to store and process information in a fundamentally different way. This mind-bending concept is key to unlocking the power of quantum computing. Now let's talk about entanglement. This is where things get really weird. Imagine you have two coins, you flip them both. If one lands on heads, you instantly know the other is tails. That's correlation. Entanglement is stranger. Imagine two entangled coins. If you flip one and it lands on heads, the other instantly becomes tails, even if they are light years apart. Einstein called this spooky action at a distance. In quantum computing, entanglement allows qubits to be linked together. This creates a massive interconnected system. The more qubits, the more powerful the computer becomes. Section 5. Classical versus quantum, a tale of two worlds. Let's compare classical computers to quantum computers. Classical computers are like bicycles. They are great for everyday tasks. Quantum computers, on the other hand, are like spaceships. They can travel to the stars. Classical computers use bits, which are like tiny switches that are either on or off. Quantum computers use qubits, which can be both on and off at the same time. This allows them to perform multiple calculations simultaneously. Quantum computers are not meant to replace classical computers. They are different tools for different jobs. Section 6. Quantum leaps in the real world. Quantum computers are not just a futuristic dream, they are already impacting the real world. Drug discovery. Quantum computers can simulate molecules. This helps scientists develop new drugs and therapies. Materials. Science quantum computers can design new materials with enhanced properties. Think lighter, stronger, and more efficient materials. Financial modeling. Quantum computers can analyze financial data and make predictions with greater accuracy. These are just a few examples. As quantum computing evolves, its impact on our lives will only grow. Section 7. The quantum hurdles, challenges, and limitations. Quantum computing is still in its early stages. Building and operating these machines is a complex and challenging endeavor. Qubits are fragile. They are extremely sensitive to their environment. Even the slightest disturbance can cause errors. Scalability. Building large-scale quantum computers with millions of qubits is a major engineering challenge. Cost. Quantum computers are currently very expensive to build and maintain. Overcoming these challenges is crucial for the future of quantum computing. Section 8. On the horizon, quantum computing's bright future. Despite the challenges, the future of quantum computing is incredibly bright. Error correction. Scientists are developing techniques to correct errors in quantum computations. New qubit technologies. Researchers are exploring new ways to build more stable and scalable qubits. Quantum software. New programming languages and algorithms are being developed specifically for quantum computers. The quantum revolution is just beginning. The possibilities are limitless. Section 9. Embrace the quantum revolution. The world is changing at an unprecedented pace. Quantum computing is one of the most transformative technologies on the horizon. This is not just about faster computers, it is about solving problems that were once considered impossible. It is about unlocking new frontiers in medicine, materials, science, artificial intelligence, and beyond. Embrace the quantum revolution. Learn about it. Be curious. The future is waiting to be explored.